Okay, there we go. Okay, perfect. Okay, so I don't know about you guys, but I have definitely cheated on at least one assignment in my entire high school life. And that might be a little bit of an under-exaggeration, because I've definitely cheated on at least one or two more assignments. But unfortunately for my teachers, but luckily for me, I'm not the only one. That's because numerous studies by the International Center for Academic Integrity actually show that a majority of high school students admit to cheating on their homework assignments, with even over a third admitting to using ChatGPT or the internet to plagiarize every single assignment. And unless you've been living under a rock, you know and understand that generative AI like ChatGPT have pretty much taken over every single part of our daily lives, especially academically. That's exactly why Forbes actually reports that around 90% of students have admitted to using ChatGPT for their homework assignments in the past. And because of this, people have tried to solve this issue in two separate ways. First is traditional AI detectors, and as the name implies, you detect for AI. And it does so by looking for certain characteristics that give signs towards someone using AI to write their writing. But that's exactly the problem. AI detectors right now only analyze one text by itself without considering how someone wrote previously. So if someone like you maybe just had certain flags or certain behaviors that AI had, you could be incorrectly classified as being written by AI. The second method is AAV detectors, which is the premise behind my project, which stands for authorship verification. And basically, AV is a task of figuring out if someone was in fact the author of two different texts. As you can see at the very top, if it would zoom in, you have text one and text two, where text number one you know for sure was written by one author, and text number two where you're not really sure if the same author wrote it as well. And from here, AV is basically the task of figuring out if someone did in fact write both of the same text. However, the problem with these current models right now is they effectively fail to capture the nuances in someone's writing style, which I actually hypothesize that by analyzing the nuances and the ways someone varies in their writing style from a more nuanced perspective would be much more indicative if someone did in fact write both of the different texts. Therefore, my project aims to fill this particular gap. It adapts AAV for this current era of generative AI by integrating and developing a novel set of writing style features to more capture the nuances and subtle changes in someone's writing to figure out if indeed they were being academically dishonest. So for the research problem once again, the current AI detectors and AV detectors fail to capture the nuance changes in writing styles, which is why we both can't rely on them in the current status quo. Therefore, my hypothesis in question was what if, in this current era of generative AI, would a comparative AV approach, which looks at the more nuances in someone's writing style, be more indicative if someone was in fact academically dishonest? And therefore, once again, my project adopts AV for this era by integrating a novel set of writing style features, allowing teachers or even the general public to figure out if someone was academically dishonest. Now, for the engineering design, obviously my project is an engineering project because I'm developing a solution for a particular problem, which I particularly enjoy because I like solving problems, especially when they impact a lot of people. And my entire design was following a feature vector model, which I will explain more in the methodology section, but essentially it came about in three separate parts. First was data collection and preprocessing, second was feature development and extraction, and third was machine learning classification, which we'll all dive into right now. Let's talk about the bulk and the main portion of my project, which were the methods and procedures. Although all of the procedures and developments were done independently, there were a couple of things that made my life easier. First was my lovely MacBook Air M2 chip from 2022, which I'm currently recording this video on. Number two was Python, because all of my programming in this project was done in Python because it is number one, a computer science project, and number two is a machine learning one, which Python is a universal programming language. And most importantly, all of my source code for my entire project can be found on my personal GitHub repository, which means that anyone in academia, including yourself, or anyone in the public can go to my code, use my features, or use my model as a whole to figure out if someone was academically dishonest. And there were a couple of notable Python libraries and system softwares, which I'll refer to throughout my presentation. Now, for the data collection and preprocessing, in a machine learning project, when you're training a model to learn from data to make a prediction in the future, you have to have adequate data to help the model learn when a certain case is which case. And because of this, I collected two separate data sets for my collection. First is Reuters 50/50, which is a pretty common news outlet website, which basically you have 5,000 total different texts with multiple texts for multiple different authors. This data set is really good because it allows us to figure out if some will sample different cases where the same author wrote different texts and similarly where multiple authors wrote different texts as well. The second one was actually real high school students' essays, because obviously my project is on academic dishonesty, so I figured it's probably pretty important for me to have a data set that exactly mimics a real academic setting, which is where that data set comes in. Now for the pre-processing part, in a machine learning project, especially one that's text-based like myself, pre-processing is extremely important to filter out unnecessary parts that can skew the data extraction and feature extraction in the later steps. And for example, to help you like envision why pre-processing is so important, is say for example you had a random dollar sign in the middle of your sentence. That could completely skew up any metrics like maybe readability, where a random dollar sign could completely mess up the readability of a text or any other features which I'll explain later on. So that's why pre-processing was integral for my project. The next part was actually creating unique and balanced text pairs. What I mean by this is essentially whenever you're developing a machine learning model, especially one where you're saying yes or no to someone cheated or someone didn't cheat, you have to feed them both cases or give the model a taste of both. Because in order for it to figure out if someone did cheat or if someone didn't cheat, you have to give it an idea of what each looks like, which is what 0 and 1 represents. 0 represents different author pairs where someone had enough disparities between two different texts for that to not be the same author pair, where 1 represents same author pairs where they were similar enough to be classified as same author text pairs. So from here, we go into the most important part of my project, which was the feature development and extraction. Let's start on vocab, because one thing I noticed while developing my project, and one thing I noticed while I was personally writing, is writers very often differ on the vocabulary usage they use. Most notably, basically the range in which they use them for the difficulty. And in order to measure how much someone varied upon their vocab usage, I use CEFR, which stands for the Common European Framework Reference. Essentially, it's used to figure out if someone or the ways in which they use vocabulary, ranging from A1 levels all the way to C2 levels, where A1 levels represent the most common form of words, like maybe I, have, book, and etc., while C2 words represent more advanced or uncommon words that you only really see in academia. As you can see in these two images, author number 1 with pair 162 text 2 actually saw a more proportionate higher use of A1 words, while a less proportionate use of C1 and C2 words. On the other hand, author number 2 here had a less proportionate use of A1 words, while a lower or higher proportionate use of B1, B2, C1, and C2 words. So what this feature does is it helps encapsulate how someone writes based upon the difficulty of their vocabulary levels, as well as the range and variety at which they use them. Next one is sentence length and variance, because writers also differ on how they vary their sentence lengths and variety. Because one thing I personally noticed is that people very often differ on how long or how I guess, variety of the sentence lengths really are. Because whenever I talk to my English, well, I guess my biology teacher for just emailing in general, she only really responds to me in very short length sentences. While opposed to me, I like to write very extended and very long sentences, which this feature not only helps you encapsulate how someone tends to write towards a particular length, but also the variety at which they use them. Because, for example, a more experienced writer might have a more dynamic writing style where they switch from very short sentences to very long sentences and back to back to back, while some other more inexperienced writers may only stay at a particular length for the entirety of the writing, which is more of a monotone writing style. So this feature not only represents how someone tends to go towards one particular length, but also how they vary across their entire writing. Next feature is readability, and it's pretty intuitive as how readable someone's text is. Essentially, people also differ on the ways in which the texts are readable, which the readability is measured by the Flesch reading ease test, basically based upon the average sentence length and average number of syllables. Because some people like to write very overly extended sentences or very overly complex words, which is readability perfectly helps you encapsulate. As you can see here, this author at the very top had a much higher readability compared to the other ones which had a much lower readability. So this feature helps us figure out how readable someone's text upon averages really is. Next feature is perplexity, which is basically the measure of how predictable someone's text or sentence is. And to help you envision what perplexity actually refers to, I have a quick example here. So tonight I'm going to eat blank. Because people obviously don't eat metal, there's a lower probability of someone saying I'm going to eat metal. But because perplexity has an inverse relationship with predictability or probability, a lower probability actually would indicate an inverse higher perplexity. On the other hand, because people actually eat pizza, there is a higher probability, but in the inverse, a lower perplexity. And this feature is basically used to figure out how coherent or how predictable someone's text or writing really is. As you can see here, author number, well, I don't know which author this is, maybe author number 30 or something, has a very high level of perplexity on average, while this other author has a very low perplexity on average, which this feature basically helps you encapsulate how they differ based upon their levels. Next one is sentence structure variation, because writers also differ in how their writing differs for the preferences in which they like to write. And I categorize the sentence structures into 6 different categories, going from simple, compound, complex, fragment, and unclassified. Now, this feature essentially helps you encapsulate how someone has a preference for certain types of sentences that they form. For example, author number 1 uses a more balanced, or not really, yeah, sort of a more balanced distribution of sentence structures, with a pretty much equal amount of simple, and compound complex sentences. However, author number 2, on the other hand, have a very clear preference for complex sentences, while less proportionate amount of the other ones. So this feature essentially helps us figure out if someone was indeed academically dishonest by analyzing the ways in which they have preferences for the sentence structures they form. Next feature is adverbial placement. The premise is kind of similar, and it's basically that adverbs or writers also differ in their preferences for where they want to place their adverbs. And these are classified once again into 5 different categories. For example, looking at sentence initial as the name implies, the adverb is in the initial part of the sentence. So quickly he packed his bags. On the other hand, for preverbal, he quickly packed his bags, where the quickly is right before the verb. And as you can see in these 5 examples, all of these sentences mean exactly, almost identically the exact same meaning. However, they differ on where they want to place their adverbs, which this feature aims to encapsulate. So for example, here you can see that author number 1 has a more balanced use of adverbial placements. However, author number 2 has pretty much only uses preverbal placements for all of their adverbs. So this feature effectively lets you figure out if someone has a preference for where they place their adverbs for the ultimate idea and the ultimate goal of figuring out if someone was academically dishonest. Now for the more computational part of my project, which was the machine learning classification. So I model AV as a binary classification task because earlier I mentioned I created 0 and 1 label pairs to feed the model a taste of both cases. And essentially, the binary classification task is basically inputted with a feature vector, where a feature vector, as you can see in the very bottom, is a list of numbers with corresponding to each feature with a label at the very end, with 0 or 1. So each of these numbers represent the disparities between one feature, like one text's feature value, to another. So essentially, whenever the differences are big enough, the label is classified as being 0, representing different author pairs. However, when the disparities are not big enough, they're classified to be 1 label pairs instead, representing same author pairs. So essentially, because AV is modeled as a binary classification task where either someone cheated or they didn't cheat, a feature vector with 0 and 1 is inputted into the model to give the taste of both and ultimately figure out in the future if someone did in fact was cheating. From here, I train my feature vector models and all my samples upon 5 different binary classification machine learning models to figure out if someone was academically dishonest, which I'll discuss the results right now. Now for the results and analysis, the most important part was a top performing model, because out of all 5 of the models I tested and trained upon, the tuned gradient boosting model was the most performative. And probably the reason for why is because of its ability to capture non-linear relationships and subtle variations between features. Because looking back at the feature vector sample I had here, it's pretty not intuitive to think that every single of these numbers would be in a linear relationship or very obvious pattern. Therefore, gradient boosting stands out upon the other models in its ability to effectively capture the very subtle changes in someone's features to figure out if someone was or someone wasn't being academically dishonest. And now for the most important part of my project and the part I'm the most proud of, which is my model's comparison to the current state-of-the-art models right now. So at the very top, you can see two different tables, and these tables have the model's name as well as the different performance evaluation metrics for which my model was trained upon. And most importantly, across every single one of these performance evaluation metrics, my model actually ended up outperforming the state-of-the-art model, which also used a feature vector model for their classification, which was one in 2024. And this is extremely promising because it shows that my smaller novel set of writing style features ended up outperforming the state-of-the-art more complex features, which shows that analyzing the nuances in someone's writing style is actually more indicative if someone was being academically dishonest, which shows very promising results for the future if anyone wants to use my feature set to improve upon their existing models. Now, for the final conclusions and takeaways, once again, my entire project was developing a authorship verification feature vector model to figure out if someone was being academically dishonest in this current era of generative AI. And my novel contributions are as follows. First and most importantly, I outperformed the state-of-the-art models on the exact same dataset, which shows that my novel set of writing style features are more indicative if someone used AI or if someone was being dishonest in an academic setting. Number two, I presented and developed 6 novel writing style features to analyze writing style, which advances the AV literature, so if anyone in academia wants to use my model or use my features in the future to either detect AI, detect dishonesty, or even use my features to improve their own models, they can. And third and finally, I trained and evaluated and compared 5 different machine learning models and figured out that gradient boosting was a top performing model, which shows that gradient boosting is the most performative and most fit for this AV task. And most importantly, my entire project is soon to be developed into a production ready website for academia and K-12 teachers to use to have a real world impact. But once again, all of my findings can be found on my GitHub repository, so once again, if anyone like yourself or anyone in the public wants to use my programming and code right now, they can. And for the economic feasibility, great news, it's completely free, assuming you have a device, but I'm assuming if you're a teacher and if you're trying to look for academic dishonesty, you probably do have a device. So that's good news there. Now for the limitations and future work, although my model did end up outperforming the state-of-the-art models, the accuracy of course always could be better. That's where I want to in the future collect more datasets with a more wide range of topics that further resembles an academic setting. From here, we hope that in the future, the model will have more representative data and more data overall to get a better gauge of if someone was being dishonest in the future for classification. And here are some of my key references. And once again, for acknowledgements, my entire project was done independently, but there were a couple of groups of people or people that made my life easier. First was Z Lee, who was a person who curated the Reuters 50/50 dataset, which I couldn't have trained or developed my model without, which I'm gratefully thankful for. Next group of people were my lovely high school classmates, which were able to give me their own data and their own essays for me to train my model on, which I obviously couldn't have done without. And finally was Stephanie Wan, who was a person I compared to where I gained some inspiration from for the data pair curation function, as well as compared my model to their model to figure out if my model was comparatively performative and was competitive with the state of the art. And that's pretty much it.